Okay. Hello, my name is Timur, and for 5 minutes back of an envelope calculation done by students, I would like to draw your attention to something that we usually take for granted, and that is oxygen in our breathing air. And all oxygen on our planet was and is produced by photosynthetic organisms. And it is thought to be very important for development of complex life as we know it. And so when planetary scientists are looking for extraterrestrial life beyond our solar system, they're first looking for oxygen. It is thus ironic that how oxygen first arose on our planet is currently unknown. Let me summarize what we know right now. On y-axis would be amount of oxygen in the air in comparison to current levels. So starting from 1000%, 100%, 1%, 10 to the minus 3, 10 to the minus 4, 10 to the minus 5. And on x-axis would be time in billions of years ago. So our planet is 4.5 billion years, I don't know, have time, 4.5. And many lines of evidences suggest that before 3 billion years ago, amount of oxygen in the air was at least below 10 to the minus 5 of the current level. And around 2.5 billion years ago, something happened which brought it to around 1% of current level. And then around 1 billion years ago, another rise happened which brought it to around current level. So this first rise was called Great Oxidation event, and the best estimate that we have on its duration is around 150 million years. Is it a long time? If you would take a whole life of our planet and squeeze it into one day, Great Oxidation event would take around 20 minutes. And if you would think about organisms that pull that off, there were no forests, rainforest or of any other kind. Only photosynthetic bacteria were around, like cyanobacteria that we have today. So I would like to ask you a question. How many of photosynthetic bacteria do you think would be sufficient to pull that off, to convert the atmosphere of the whole planet in 20 minutes in comparison to life of the planet? So written on the desk, this question sounds like, what is the number of cells? And to answer this question, we would really need only two numbers. First, we would need efficiency of oxygen production in mole per cell per unit of time. And we would also need amount of oxygen in the air in moles. So first number, we can it's a derivative of a few numbers from a bi-numbers database. And for cyanobacteria, a relevant organism, it's around 2 femtomole per cell per hour. And for amount of oxygen, it's around 4 to 10 to the power of 19 mole. And we need to convert time to relevant units, which is hours. So 1.5 to 10 to the power of 2 to 10 to the power of 6 millions to 10 to the power of 4. It's a number of hours in a year. So we arrive at around 2 to 10 to the power of 12 hours. OK, so number of cells that we're seeking is it would be amount of oxygen in moles divided by efficiency of oxygen production in mole per cell per hour multiplied by time in hours. So it's around 4 to 10 to the 19 mole divided by 2 to 10 to the power of minus 15 femtomole cell hour multiplied by 2 to 10 to the power of 12 hours. So we arrive at a number 1 to 10 to the power of 22 cells would be needed to convert the whole atmosphere of the planet in a very short time. So it's really not a big number because if you would think about a monolayer of these cells, it would take approximately around 1/1,000,000% of the surface area of our planet. And if you would compare the volume of these cells to the volume of the atmosphere that these guys converted, it's around only 1/1,000,000,000% of the volume. So very efficient little guys. And when next time you would see greenish stuff in an old pond, take a moment to appreciate that these guys did for a complex life on our planet. Thank you.